Hello, good morning. This is your first lesson in chemistry, and today we will be talking about intermolecular forces in liquids and solids. I am Miss Sandra, and I will be your instructor all throughout this summer class. So if you have any questions regarding this lecture, you will be posting them under the discussion forum. So let's start. Let's talk about liquids and solids first. Let's have a brief review. So solids and liquids are also known as the condensed states. This has been introduced to you, no, since elementary and high school. The liquid and solid states have many similarities and are significantly different from the gaseous state. At ordinary conditions, the particles of a liquid or a solid are very much closer together than those of a gas. So let's take a look at this slide. So if you're going to look at here, the solid particles are compact. They are tightly packed. They are close to each other, no? And the particles of your liquids, they have small spaces between them. So the particles of your liquids, they slide past each other. So can you still recall kung anong itsura ng particles ng ating gases? Yes, that's right, no? They are far apart from each other. Mas malalayo sila sa isa't isa. So let us recall, how do solids and liquids differ from gases? Solids and liquids are denser than gases. Liquids and solids, they are not very compressible due to the lack of space between the molecules. And that is evident naman from the previous slide, no? Kasi mas dikit-dikit kahit papano yung kanilang particles, especially the solids. The intermolecular forces of attraction are strong enough to hold molecules together or to keep them in locked position. So this is what we are going to talk about today, the intermolecular forces of attraction between these molecules, no? How this attraction holds the particles together. Okay. So this is just a summary of the properties of your solids, liquids, and gases. I wouldn't delve deeper much into this because, as I mentioned a while ago, you've already learned this during your elementary years and your junior high school. Now let's go to the main topic. So today we are going to talk about your intermolecular forces. So intermolecular forces, let's write that down. Intermolecular forces of attraction. So para hindi tayo malito, no, I will be addressing this all throughout the lesson as IMF. So IMF, whenever I say IMF, it only means intermolecular forces of attraction. Okay, so what is the difference between your intra and your intermolecular forces? So intra versus inter. What's the difference? Your intramolecular forces holds atoms together in a molecule. These are forces that occur within the molecules. So say for example, we have water, diba? This is the structure of your water. Okay, so this is your water. Ano yung intramolecular forces of attraction? Yung intramolecular forces of attraction, it is within the molecules. So it means that is the attraction between your atoms, your hydrogen atom and your oxygen atom. This is your intramolecular force. Anything, any force acting within the atoms, no? From one atom to another, that is intramolecular forces. Those are your ionic bonds and your covalent bonds, if you can still recall that. So, chemical bonds such as ionic and covalent bonding involves intramolecular forces. So, if you can't remember it anymore, diba? Pag ionic bonding, what happens to your electrons? They are transferred, diba? Transferred, ayan. Kapag covalent, what happens to the electrons? They are shared, no? So basically, intramolecular forces, these are forces that bonds your atoms together. Okay, I hope that is clear. Now let's go to intermolecular forces. So intermolecular forces, on the other hand, are attractive forces between molecules. So say you have another water molecule here. Alam na natin na kapag yung force ay nag-act within the molecule between an atom to another, This is intra. Now, paano yung inter? Pag inter, you have another molecule of water here. Ayan. So, we have another molecule of water here. Nag-a-attract siya with another molecule. Ayan. So, there is... Okay, let me change the color of that para mas makita ninyo. So, ayan. So, there is attraction between molecules. So, you have one molecule of water here and another molecule of water here. Kapag intermolecular forces, nag-a-attract yung dalawang molecules. So, pag inter, between atoms, pag intra, that is between atoms. Pag inter, that is between one molecule to another molecule. And generally, intermolecular forces are much weaker than intramolecular forces. What does that mean? Ang intermolecular forces of attraction ninyo, mas mabilis ma-break yan. Mas mabilis ma-break yung bond compared with your intramolecular forces. Mas mahirap i-break yung bonding between an atom to another atom kesa sa molecule to another molecule. Okay, so I hope that is clear. So your intermolecular forces, they are also known as your van der Waals forces. So intermolecular forces, they are also known as your van der Waals forces. So you don't pronounce this as van der Waals. Waals. This is van der Waals, no? So this one, you pronounce it as F. So van der Waals, no? It's not van der Waals, it's van der Waals. Van der Waals forces. Okay, so this is just an illustration just to help you visualize the difference between intermolecular forces and intramolecular forces. Let's try to Let's try to write on the slide. Okay. So, intra, kung titingnan natin yung intra, this is your intra. This is the bond between your hydrogen and your chlorine. An atom to another atom. Kapag intermolecular forces, you have one molecule of hydrogen chloride. It has a weak bond that is formed to another molecule of hydrogen chloride. So again, pag intra, atom to atom. Pag inter, it is molecule to molecule. Ayan. I hope that is clear. Okay, let's move forward. Now, let's talk about the types of intermolecular forces. Okay. So, we have dipole-dipole forces. Dipole-dipole forces are attractive forces between polar molecules. So, the key word here is polar. Next, a polar molecule is described as a dipole. Polar molecules have permanent dipoles that align so that opposite charges are close to each other. I think you might have a difficulty in understanding this if you're still not familiar with the concept of the dipole moment. So before we delve deeper into the concept of dipole-dipole forces, pag-aralan muna natin ano ba yung ibig sabihin ng meron kang dipole moment. So, if you recall from your Gen Chem 1, your metals, they are usually what? They are usually positive charge, no? Kapag non-metals, they are usually negatively charged. And usually, your non-metals, they are electronegative. So, pag sinabi mong electronegative, ano nga ulit ibig sabihin nun? It attracts electrons to itself. So, if you're going to look at your periodic table, di ba? Your electronegative atoms are on the far right side. Nandito banda. Sila oxygen, sila fluorine, sila nitrogen, so on and so forth. So, paano nagkakaroon ng dipole moment? O, paano tayo nagkakaroon ng dipole moment? Let's see. Say, for example, we have OH, no? Okay, so we have your OH. So, this is negatively charged. Okay, yan. Meron tayong OH, no? So, you all know that oxygen, since it's on the far right side of the periodic table, it is negatively charged. And your hydrogen, dahil nandun siya banda sa left side, no, it is positively charged. May dipole moment ba tayo? Yes, there is, because there is difference in charge. Saan papunta ang dipole moment mo? Papunta doon sa negatively charged. So, is OH a polar molecule? Yes, it is a polar molecule. Why? Because it has a dipole moment. So, dahil meron siyang dipole moment, what type of intermolecular forces can this OH molecule form? It can form dipole-dipole forces. Ayan. It can form dipole-dipole forces. I think this is clear. Let's have another example. Let's say we have carbon tetrachloride. Carbon tetrachloride. O ganyan itsura ng carbon tetrachloride. If you're going to look at the position of these elements in your periodic table, itong si chlorine ay mas nasa left. Basta mas nasa left side ng periodic table, automatic mas negative siya, no? Mas nasa taas at mas nasa left side ng ating periodic table, negative ang charge. Okay, so dahil si chlorine ay nasa farther left side ng ating periodic table, ang kanyang charge ay negative. So it is negatively charged. How about your carbon? Of course, it is positive in charge. Now, so since your carbon is now positively charged, the question is, does your CCl4 or your carbon tetrachloride have a dipole moment? Let's see. Let's see. Let's use another color. Okay. So this one, this positive, di ba, ano sabi natin? Mas negative yung atom, mas electronegative, mas hinahaltak niya yung electrons papunta sa kanya. So, itong si positive natin dito, yung electrons ng ating carbon, hihilain ni chlorine papunta dito. Eh, negative din dito sa left side. So, hihilain din niya papunta dito. Is there a net dipole? Wala. Kasi they are pulling the electrons on both sides. So, magka-cancel ito. Next, itong chlorine sa taas, hihilain niya yung electrons ni carbon pataas din. And then si chlorine here sa baba, hihilain din niya yung electrons ng carbon papunta sa kanya. So, is there a net dipole? Wala po. Bakit po? Kasi naghihilaan din sila pataas. So, walang specific na direction pupuntahan yung electron. So, this will cancel out. So, is there a net dipole? E nag-cancel lahat ng arrows natin? Wala po. So, there is no net dipole. So, carbon tetrachloride does not have a dipole moment. That means it's not what? It's not a dipole molecule. It's not a polar molecule. So, your carbon tetrachloride is not a polar molecule. Therefore, the question is, may dipole-dipole forces ba siya? Wala po. Wala pong dipole-dipole forces si carbon tetrachloride. Kasi carbon tetrachloride, kung hindi siya polar, it is a non-polar molecule. Ayan. O later, we'll get back at this one para mas maintindihan pa natin. Ano? Okay. So, this one, I've already explained this, no? So, if you're going to look at this, sige, explain na rin natin, no? If you're going to look at this example, you have hydrogen chloride. Hydrogen chloride. And si chlorine, nasa ang side ng periodic table, mas nasa left kesa kay hydrogen. So, sino ang negatively charged? Si chlorine. Chlorine is negatively charged. At dahil si chlorine ay negatively charged, yung isa ay positive. Pero it is not fully positive, no? Bakit? Kasi naghihilaan sila ng electrons. So, the proper term is, this is partial negative, this is partial positive, partial positive, partial negative. Okay. Let me fix that. Ayan. Partial negative. So, the question is there a dipole moment between hydrogen and chlorine? Is hydrogen chloride a dipole or a polar molecule? Ayan. Let's use polar molecule. Yes, it is. Bakit? Kasi this is positive, this is negative. Saan papunta ang electron? Sa negative side. So, lahat ng electrons sinahaltak papunta kay chlorine. So, automatic, hydrogen chloride is a polar molecule. So, if it is a polar molecule, anong type of intermolecular forces ang nag-e-exist? Lagyan natin dito, type of IMF. It is dipole-dipole forces. So, pag nag-attract sila, ayan, magke-create sila ng bond. Sorry, hindi dapat ganyan ang itsura niyan. It should be dots. Ayan, kasi breakable ang kanilang bond. Ayan. So, chlorine, being partially negative, will be partially attracted to the partial positive of the other end of the hydrogen chloride. So, that is your dipole-dipole interaction or your dipole-dipole forces. Now, let's go to dispersion forces. So, dispersion forces, so what's the first type? The first type of intermolecular force is what? The dipole-dipole forces. Oh, let's put that down here. Dipole-dipole forces. What's the second type of intermolecular force? It is London dispersion forces. Dispersion forces. Pag London dispersion forces, they are also known as your induced dipole forces. Okay, bakit kaya? O, tingnan natin ha. Dispersion forces are present between molecules of all molecular substances. Your London dispersion forces, no, they are also known as your van der Waals forces. At lahat ng molecules, meron silang London dispersion forces. So, kung babalikan natin ito, a molecule ha, hindi lang pwedeng isa ang type of intermolecular forces niyan. It can be 2 or more, no? 2 or more. So, let's try to look at this one. So, is CCl4, okay, this one, the first example, sabi natin it's polar, it has a dipole moment, so dipole-dipole forces of attraction. Tama naman. Pero sabi din natin ngayon, lahat ng molecules may dispersion forces. So, itong OH molecule ninyo, OH negative molecule ninyo, meron rin siyang dispersion forces. So, pag tinanong kayo, what are the types of intermolecular forces in the OH molecule? It is dispersion forces and dipole-dipole forces. Ayan, lahat ng molecules ha, may dispersion forces. O si carbon tetrachloride, sabi natin non-polar siya. Pag non-polar ang molecule, automatic, isa lang ang kanyang type of intermolecular force of attraction. Automatic, kapag non-polar, dispersion forces lang ang meron. Okay? O this one, the hydrogen chloride molecule, sabi natin, this is polar. So, anong type of IMF meron siya? Dipole forces. Dipole-dipole forces. Yun lang ba? Hindi. Kasi nga lahat ng molecule may dispersion forces. So, si hydrogen chloride, meron siyang dispersion forces, meron din siyang dipole-dipole forces. Okay, I hope this is clear. Lahat ng molecules may London dispersion forces sila, ha? Dispersion forces are the only force of attraction between non-polar molecules. Kaya nga kung babalikan natin si carbon tetrachloride, wala siyang dipole moment, di ba? Pag walang dipole moment, automatic non-polar. So, kapag non-polar siya, automatic ang meron lang sa kanya ay dispersion forces. So, nakukuha nyo na yung technique. If you are asked what type of interactions are present in the molecule, tingnan nyo muna. Step 1, pag tinanong kayo, what are the type of interactions in the molecule? Step 1, identify first. Identify if there is a dipole moment. A dipole moment o yung tinatawag nating net dipole. Kasi kapag meron siyang net dipole or meron siyang dipole moment, so kapag meron siyang net dipole, automatic yung ating molecule ay polar. At kapag siya ay polar molecule, automatic, ano ang kanyang IMF? Ang kanyang IMF ay dipole-dipole forces, no? Dipole-dipole attractions. Ayan. Dipole-dipole forces. Next. Paano kapag non-polar siya? If it doesn't have a net dipole, so wala siyang net dipole, automatic yung ating molecule ay non-polar. So, dahil non-polar siya, ayan, wala siyang net dipole, automatic ang kanyang IMF ay ano? London dispersion forces. O, let's have an example. Ayan. Sabihin natin, we have, ano bang magandang molecule? Boron. Okay, sige. Let's have another molecule. Balikan na lang muna natin yung previous example natin, no? So, we have, okay, sige, let's have ammonia. Ammonia has a, ayan, medyo mahirap na to kasi may symmetry na tayong pag-uusapan. So, wag na muna ito. Let's go for planar molecules muna. Later, we'll talk about geometry, no? You'll understand bakit sinabi ko yon regarding ammonia. So, let's say we have, ano ba? O, balikan na lang natin yung previous example natin kanina. So, carbon tetrachloride ulit. So, sabi ko, basta mas negative ang molecule, ano mangyayari pag mas negative ang molecule? Siya ay nasa form ay negative, no? So, yung nasa carbon ay positive. Tandaan ito, no? Anong sabi ko? Step 1, identify muna kung may dipole moment o net dipole. If the arrow are on opposite directions, automatic nagka-cancel sila. No? Parang sa physics lang yung sa vectors, di ba? Kapag they are on both directions, nagka-cancel. So, ganyan lang din sa chemistry, no? So, pag on opposite directions, cancel sila. So, automatic, pag nagka-cancel lahat ng arrows na dinodrawing ninyo, yung molecule, o pag non-polar ang iyong molecule, automatic, mas strong yung magnet mo, mas negative siya, mas mag-a-attract siya ng positive. So, ganun lang din. Nag-create siya ng temporary dipole, parang magnet, na ina-attract niya yung nasa kabilang molecule. Ayan. Okay? So, induced dipoles. The formation of the instantaneous dipole in turn can affect the electron distribution of the neighboring molecule. The second molecule is induced to form a second temporary dipole. Ito yung sinasabi ko kanina. If you're going to look at this one again, okay, asan na yung aking pen? Just a minute. Ayan. So, if you're going to look at this one again, since ito ay mas negative, so ano mangyayari dun sa neighboring atom niya? Mas i-attract niya ngayon yung, okay, so yung neighboring atom niya, i-attract niya yung partial positive ngayon. The partial positive end. Ayan. The induced instantaneous dipoles lead to a relatively weak and short-lived force of attraction. Instantaneous nga lang kasi siya. Temporary lang siya. That's why it's weak. So if you're asking the exam, what is the weakest type of intermolecular force? Ano ang sagot? London dispersion forces. It is the weakest. Okay? So again, just a little recap. Pag polar yung ating molecule, dalawa yan, di ba? Meron kang London dispersion forces and dipole forces of attraction. Kapag non-polar yung ating molecule, automatic, ang meron lang sa kanya ay London dispersion forces. And what is the weakest type of intermolecular force? It is your London dispersion forces. Okay? So I've already explained this a while ago. So, strength of dispersion forces. The strength of induced dipole forces or dispersion forces depends on the polarizability or the ease with which molecule electron distribution is distorted. So, yung strength ng ating induced dipole forces nakadepende kung gaano ba kabilis ma-distort, no, yung ating molecule. Polarizability increases with greater number of electrons or increasing molar mass. Okay, so mas mataas yung ating molar mass, mas mataas yung ating polarizability. Okay, the last type of intermolecular forces. So far, what did we discuss? Ayan, let's write it down para hindi makalimutan. The first one that we've discussed is dipole-dipole forces. Followed by what? Followed by London dispersion forces. And what's the third one? Hydrogen bonding. Okay. Okay, wag itong kalimutan ha. Ituturo ko na. Hydrogen bonding is the strongest type of intermolecular force of attraction, followed by dipole-dipole forces, at ang pinaka-weak ay si London dispersion forces. So, paano mo malalaman na may hydrogen bonding? Napakadali. Basta nakita nyo si N ay nakadikit sa H, o si O nakadikit sa H, or si fluorine nakadikit sa H, automatic yan po ay hydrogen bonding. Say for example, I ask you, okay, ammonia, what type of intermolecular force exists in your ammonia? Automatic, it's OH bonding, no? Sometimes they refer to hydrogen bonding as OH bonding. So if you write OH bonding or hydrogen bonding, I will accept that. Okay. How about hydrogen fluoride? Automatic, ito ay hydrogen bonding. Bakit? Anything, no? Any bond that is between nitrogen and hydrogen, oxygen and hydrogen, fluorine and hydrogen, automatic, that is hydrogen bonding. O water. Ayan. Ano bang itsura ng ating water? Ayan. Ganyan yung ating water, di ba? O, what type of intermolecular force exists there? Of course, tinuro ko na, OH, automatic hydrogen bonding. Pero may iba pa. May iba pang type of force. Of course, automatic, may London dispersion forces siya. Bakit? Kasi nga lahat ng molecules may London dispersion forces. The question is, meron ba siyang dipole-dipole forces? Yes or no? Tingnan mo ngayon kung meron siyang dipole moment. So, si oxygen, since siya ay nasa far left side, sa kanya yung negative sign. So, partial negative. Si hydrogen, dahil siya ay nasa far left side, si oxygen ay nasa far right side, si hydrogen ay nasa far left side, automatic siya ay may partial positive charge. So, dahil siya ay may partial positive charge, saan nga papunta ang arrow? Papunta siya saan? From the positive, papunta dun sa negative. Ayan, so from the positive going to the negative, it's pointing upwards, di ba? May specific direction kung saan pumupunta yung ating electrons at yun ay pataas. So automatic meron siyang dipole moment. So dahil ito ay dipole moment, ito ay polar molecule. Ayan. So dahil siya ay polar molecule, meron din siyang dipole-dipole forces. So, it is very important actually na matutunan nyo yung skill how to identify polar and non-polar molecules. Ayan, so this is the example of hydrogen bonding, no? Between molecules. Kung titingnan ninyo class, ayan o, N to H, nitrogen to H, oxygen to hydrogen, o pwede din sa other molecules yan. Fluorine to hydrogen, ayan, hydrogen fluoride to ammonia, and ammonia to hydrogen fluoride. Okay. Ayan, so hydrogen bonding is actually very important, no? Inside our body, hydrogen bonding in water, and DNA nitrogenous bases, no? Kaya ang inyong DNA, it's held together, no? Hindi siya basta-basta na-disrupt because of the hydrogen bonding between those nitrogenous bases. Okay, so let's try this on your own. Nabigay ko na yung hydrogen fluoride, no? Pero tingnan natin ulit. So, sino ang nasa far right side ng ating periodic table? Si fluorine. Nasa right siya. So, partial, negative. Si hydrogen, mas nasa left. So, partial, positive. Saan papunta ang arrow? Galing sa positive, papunta sa negative. Meron ba siyang dipole moment? Yes po. Meron po siyang dipole moment. Dahil may dipole moment siya. O ngayon, anong type of attraction meron sa kanya? Dipole forces, 'di ba? Kasi may dipole siya eh, kasi pumupunta sa isang direksyon yung ating molecule. So, meron ba siyang London dispersion forces? Yes, meron kasi lahat ng molecules meron. Next, yung ating may isa pa. It's a bond between hydrogen and fluorine. So, it can also form hydrogen bonding. Yung methane, na-discuss ko na kanina, no? It's a non-polar molecule. So, kung non-polar molecule, kapag non-polar molecule, di ba, walang net dipole? So, kapag non-polar molecule, automatic, ano po siya? Anong forces of attraction lang meron sa kanya? London dispersion forces lang. O sige, I'll give you 2 minutes. Try answering sulfur dioxide. Sige, try it on your own. Tapos, saka ko sasagatan. Okay? So, sulfur dioxide, ano bang itsura ng